News is that there is not a thief in our school. The bad news is that because that's the case, I did not bring you guys donuts today. But we're doing pie day tomorrow, and I'll bring salmon berry pie. Cool. Yeah, I think. I don't know. Salmon berries are pretty moist. I don't know the right way. I'm gonna have to go get some gelatin or something. Anybody in here vegan or vegetarian, and you will not eat gelatin? Do you know how gelatin's made? Cool. All right, it's collagen. Yummy. All right. So looking at these, the biggest issue that I saw you guys starting with with regards to half angles is how do we decide? Like the most common mistake that I saw you guys making up on the board, and you guys erased them, which is cool, was that when we're doing this, people naturally try to just jump in and do this. And this one, I'm going to write my ugly fraction for a second. How many of your group started with this? And this is your initial thought. Makes sense. It's natural that you would start with this. But if I spend just a second and I write this like a human being, pi 12ths divided by 2 is the same as multiplying it by what? So if this is what I had written, this would really be finding the cosine of pi 24ths, and it's too small again. Okay, we're going to work one more. I gave you the one with radians very intentionally because it's kind of uglier. I would prefer, honestly, if you guys would stay in radians, but you don't have to. Like, I'm not going to be in your mind listening to your thoughts when you decide to think of 30 degrees instead of pi 6. You're allowed to switch those things. I want you to get used to radians because they're not arbitrary and nonsense, but cool. They're not really nonsense. Degrees work fine. They're just whatever. Okay, let's do another one. So let's think of another half angle that we can work out. I need any angle on the unit circle that if you cut it in half, does not give me a different angle on the unit circle. You need to look at your unit circle to get that. For example, pi 6 doesn't work. Sorry, pi thirds doesn't work. Why? Because half of it is pi 6. I want you to find an angle where that doesn't happen. You can give it radians, you can give it in degrees, I don't care. Just half of an angle that isn't on the unit circle. So that's a great question. Every value is there, but it's not going to be labeled. Any amount of rotation, every infinitely many of them will be on the unit circle somewhere. Like, that's a great question. One that's not written. And I saw Karina had one ready to fire right away, but I'm not necessarily committed to that. Pick something in quadrant 3 or 4. Three pi fourths. Okay. Now check this out. I'm going to do a little bit of work here, and you're going to pretend like we didn't all hear that. Everybody hear the number? Gosh, dang it. Should I just pick a different one? We'll use that one. I'm cool with that. But it's going to look a little bit different. We're going to work one example together. Whether we do sine or cosine, doesn't matter to me. We'll do one of them. Looking at this, here's what I want us to think of. I want us to find sine or cosine. Which one? Like, they're about the same. Sine, sure. Way to commit to it. Appreciate that. I want us on this first one, and it might be the last one, to be honest. I want us to find the sine of 3 pi 8ths. And I want to make sure that, like, if it's not immediately clear, that we do have a way to get down to this. Now, for this, the first thing that I would always encourage as we look at this is that on the unit circle? We should always check. I just folded this up because it's going to throw it away. Is this just trash? Okay. Yeah. I just started folding it up out of habit. Addison, what do you think? Can you find me 3 pi 8ths on your unit circle? Okay. Now, I do want to commend, I don't remember who it was, but group 3, whoever you are, you guys were rock stars, because I didn't specify on the problem when you guys walked in to use half angles, and they had already started trying to write it as a difference of two different things, which you could do. We were doing 15 degrees on that first problem is what it was in degrees. They viewed that as 45 minus 30 instead, which is awesome because you can do the difference rule. I really want to focus on the half angles just in case it's not easy to find. Now, when we're doing these, we all heard the number this came from, I think. But if I wanted to know if this is half of something, how would I find what it is half of? One more time? So yeah, we could multiply it by 2. I'm just going to say 3 pi 8ths, and I'm going to write this out a little bit nicer, equals 1/2. And we don't know it right now. Do you guys agree that it's probably half of some angle? And then this is where Karina's first thought was, let's just multiply by 2. Great idea. Is it very clear why we're going to multiply by 2 this time? Okay, I called this theta. On your half angles, what did we have? Like, look at your formulas we wrote yesterday. We didn't call it theta. If I call this u instead, could we solve this for u? So we figure out what is the big angle this came from. What do we get? I'm going to use actually implies instead of that arrow. We're going to try to use implies. What's u? Okay. By doing this, and that was Karina's suggestion, which we gave us 3 pi fourths. The second I write this, do you guys agree that this, the original argument, is exactly half of this u value? So you probably won't do this every time, but especially when we're doing it for the first couple times, this is valuable. I now have in front of us the sine of 3 pi eighths. And then we're just going to go a step further. I know that this is exactly the same thing as taking the sine of what over 2? I'm going to change color for this one. This is exactly half of what did we find? Louder and prouder, because you're right. 3 pi fourths. Are these the same expression? 3 pi fourths over 2. Are these the same thing? And the fact that they're the same thing gives us the end to this problem, unless you want to use sum and difference, which is completely valid. What is u in this? Like, even if we didn't have the scratch word, can you tell me that this looks just like the forms we wrote down yesterday? So what's the rule for the sine? And I honestly don't remember it. I don't know if the sine of u over 2, I know there's a plus or minus. What I don't remember is if it's a 1 minus cosine or 1 plus cosine. 1 minus, thank you. This is the rule that we had from yesterday. And as long as we can look at what we've just done and say, wait a second, I know what u is, we should be okay. What is u in our problem? So let's just try this formula. So it's just equal to, and I'm going to keep the plus or minus for now, the square root of 1 minus the cosine of what angle? What was u? 3 pi fourths over 2. And I'm going to fix that because I hate the way it looks. It's because my font is too. 3 pi fourths over 2. Okay, now some interesting differences in algebra, which is totally okay because there's a lot of different ways that one can do algebra and still be correct. I'm going to close this door just because I can hear Russell and it's distracting me. Okay, a few alternative approaches. You guys all got the same answers up here. This group, your algebra is different than mine. I love this, by the way. It's not the way I'm going to do the problem, but what I really love, whoever this was, they recognize that you can split the square root of a fraction as a fraction of the square roots, and they split it. And then they said, wait a second, we need to rationalize this. And they rationalized. Now, we definitely do need to rationalize, make this no square root in the bottom is all that means. I'm going to do it a little differently, though. Now, I'm going to write gigantic square roots so we can see all the work, but let's just go a step further. Do you want to think about the plus or minus now or save it till the end? Now, you said red? Sure. Okay, which quadrant is 3 pi eighths in? Is it? Well, where's 4 pi eighths is pi halves, right? So which quadrant? Well, if it's 4 pi eighths, it would be on the line. It would be that quadrant. But is 3 pi eighths more than pi over 2 or less than pi over 2? If you needed to convert and you're not sure, just check this out on the unit circle. This up here is pi halves. Are we all okay with that? Or if, because I'm thinking of the eighths, could I say that that's really 4 pi eighths? Is that still pi halves? Are we bigger or smaller than this? 3 pi eighths is 1 pi eighth less. So if I'm here and here's my angle, I go all the way up to here. If I want to make that angle a little smaller, do I fall to quadrant 1 or quadrant 2? So if we're doing the sine in quadrant 1, is this a positive or a negative? Positive. I'm going to squiggle that one out, and I'm never going to write positive again. We don't need it. Did I lose anybody on how I determined that? Did I lose you, Karina? No? Okay. All right. Well, you're just going to help me work out the calculation. you're going to tell me what to put in. What's cosine of 3 pi fourths? Somebody second that. Did you actually do the math, or are you just seconding it because we trust Olin? Okay, cool. Sweet. All over 2. Now, here's where the algebra, and if you like this way, totally cool with it. If you want to split the radical, doesn't bother me. My algebra mind always says, let's just make a nicer fraction. And nicer is kind of subjective here, but I don't really like 1 minus a fraction over another one. I'm going to work and just play the algebra game to make that a single fraction. Let's clean up the numerator first. And I'm going to make a little note here just as a scratch work so it doesn't have to take a million steps. If I wanted to actually add these, which is subtracting the negative, and I'll just make that change now, plus a positive, make it look like a plus a positive. How do I do this? What do these need to have? Only the numerator. Okay, can you guys tell me the common denominator? Can I just call this 2 plus root 2 over 2? Okay, and in fact, I'm actually going to do all this on the side, but there is a nice way to do it in one step. 2 plus root 2, so bold, over 2. Okay, now when I'm thinking about this, this is a little uglier because it has a radical in it, but it's a single fraction. And dividing by 2, is there an easier way to think about that? Like a fraction divided by 2? Oh my gosh, let's just multiply by the reciprocal. Now, this line is, if you're going to get lost anywhere in here, my guess is it's here. So please be honest with me if this loses you. When I do these problems, my very next line, I'm going to make my radical as big as possible here. And it actually doesn't have to be that big here. What did we just say the numerator turned to? 2 plus root 2 over 2. And then, I don't know why every time I write a 2, it's different. I don't get it. Okay, I'm going to make everybody pause for a second because I want to make sure that you're looking when I do this. I could write it like this, 2 plus root 2 over 2, and then I could do divided by 2 again. That's an option. I wouldn't write this, Edison, but that's what the algebra is doing, right? No, you're cool. I just want to make sure, like, this one you can because this is what's happening. But unless you want a complex fraction, let's just multiply this by 1/2. And I'm going to make the comment. We'll just say because dividing by 2 is the same as multiplying by 1/2. Okay. The reason that I would do this is because I don't want to have to deal with the square root of 2 in the denominator. Why aren't I going to have to deal with the square root of 2 anymore? Why don't I have to deal with the square root of 2 in the denominator anymore like this group did? Love it. The denominator is going to be 4 when I do this multiplication, right? And do you guys know the square root of 4? 2. Now, there are varying levels of steps. Do you want me to do this in 1 step or make it 2 steps? Cool. Let's do that. So this becomes, on the very next line, 2 plus root 2 over 4. Yes, ma'am. This one? Yeah. Do you agree that if I didn't do it like this, that the line would have had to have a divide by 2? Because all I've done, this is this whole numerator, but we still have the divided by 2, so I still have the divide by 2. And then instead of dividing by 2, what's easier? Yep, and that's exactly where it came from. Yep, thank you for asking and clarifying. Okay, so we're pretty much done at this point, and it's kind of ugly, but it's nicer than infinitely many decimals that never repeat. What's the numerator? Can we simplify it at all? So the square root of 2 plus root 2, and that's all over what? 2. And we're done. Now, do me a favor. You all have wonderful calculators in front of, hopefully in front of you, but in your bag somewhere near you, I imagine. Basil, do you have like a stack of calculators from Janelle for me today? Okay. Okay. Is she still in town? Does she have a car? Okay. I was going to say, you can say no, but I can text her and make her feel really uncomfortable, and she'll bet they'll be here by the end of the day if I do that. But that's okay. Okay. I want you guys to check in your calculator the sign of 3 pi eighths. This is the same question, but I had to ask, I'm sorry. But no, you're good. The one at the top of your No, you're okay. Do you agree that just inside this is the same thing? Is that still 1 plus root 2? And then if I wanted to just combine these, could I call that 2 plus root 2? Like, that's what I'm doing. Is that, do you see it? Okay. Cool. What? Hey, I got you. I finally brought some. I brought batteries from my house, just so you know, because I'm still waiting. I tried to order them on Amazon and cancel my whole Amazon order for the school. So I ordered from Staples, but I've got you. Okay. I want you to shout out your number when you get it. Yeah. I'm going to give you 3 new batteries instead of 4. Oh my gosh, this plastic is so hard to rip. Here's 4 for you, and I'll take these 4. Okay, nobody gets new batteries other than you 2. Only replace 3 of them. And it will work, I assure you. Okay, you guys get a nice number, right? It's terribly ugly. Do me one more favor real quick, just because I'm trying to stall for time with battery stuff. Ask your calculator what the square root of 2 plus the square root of 2 all divided by 2 is. Oh, is it the same thing? Did you guys already check it? I would replace 3 of the 4 if you haven't. Yep, I would put those 2 new ones in too. Cool. Now, for these are pretty, I don't want to say like, I don't know what I'm trying to, not very often that we get ugly numbers that are exactly half angles in a problem. But if we do and we need an exact answer, your calculator has no chance of giving you the exact answer. But this does. Okay, 3 pi 8 is really how many degrees? Like, I didn't even think about it. 3 pi 8, how many degrees is that? One more time? That's not true. Sounds about right. I think I'm just trusting red there. I did not know that was coming. 67.5. Okay. Now, looking at this, is there another way you could get to 67.5? Like before on the first problem, that group, they began by doing the difference of 2 things and they erased it at this point, but they started with the difference. And we could get to the 15 degrees by doing 45 minus 30. Can you get to 67.5 by adding or subtracting? What 2 nice angles would you add to get to 67.5 on your unit circle? I can't, right? It's 30s and 45s and 60s. I can't make that be a 67.5. This is only one option, half angle formula. Okay. Feels okay, feels bad? Okay. You need some practice, I assume. Sweet. I've got practice for you. Did we just finish the chapter? Did we just finish the chapter? Let me decide if we really did just finish the chapter. Oh my gosh, we did just finish the chapter. Check for me real quick. Anybody who have an open book? Yes, please. I'm an open book, but not with you guys. Chapter 5. 5.5, it starts like 389-ish. What I'm dying to know, I don't think there's a 3.6, but I need confirmation of that. I don't know where my book is. Okay, so we just finished the chapter. Here's the deal. I think we should do the practice test tomorrow. I think we should. We're going to. Not I think we should. We are going to do the practice test tomorrow. With that said, you need time to practice this stuff as well. Cool. Now, there are a couple of formulas out there that we did not touch on, and I just want you to be aware of them. I'm not going to make you write them down right now, but I want to show you that they do exist, and I don't remember if they're on your trig cheat sheet. Okay. Do these live on your trig cheat sheet? The sum to product. Okay. If you ever had this shake out and you didn't want to square both sides and have to deal with Pythagorean stuff, notice that we have different arguments, u and v. There is a way that you can change the sum or the difference of 2 things, as long as the arguments are different, to the product. And that makes it easier to factor. If you have 2 things multiplying, that's what factoring does. Okay, there's another flavor of these. There's product to sum, which is just the reverse of the previous. They exist. There's a small chance that you would possibly have to implement these. But if it says use product to sum, is it on your cheat sheet? Oh, perfect. Cool. Well, with that said, I think this is only 5.5.2 in reality because I think I did this in 2 days instead. Here is the last assignment of the chapter. Did we have homework last night that I didn't check? Why didn't anybody tell me to check it? Add these problems to 5.5.1. And since we have a little time, would you like to check any of the ones from last night to see if they went okay? Okay, if it goes horrible, where would I advise you go on the interweb?
I tried going on it. I don't know what I'm doing wrong, but it's not like the same.
Okay, so it is, but I'm going to show you guys. Anybody try to go to Calc Chat and encounter the same issue? I'm sorry, Miss Sweet. 51 through 63 odd. And 73. Okay, real quickly, just so you guys can see it, I'm just going to type in Calc Chat rather than going to the Google Classroom. So on my phone, wherever I am, calcchat.com. What class are we in? Okay, and let's see, you're Ron Larson, and it's a 3rd edition. So Precalc with limits. I don't grab your phone right now for me. Good, I'm glad you have to stand up to get it out of the phone holder. Precalculus with limits 30. Hey, that's bright yellow and mine. And we're in chapter 5. We're in section 5. And you might have struggled hypothetically with problem 21. Precalc with limits, 3rd edition by Ron Larson. And check it out. These aren't just answers, which is in the back of your book. Every odd has a detailed, fairly detailed solution. And I recently discovered that I can just type a question into Google, and now Google AI tries to do the math stuff. I wouldn't trust it. Not consistently. Cool. Yes, I will print a fat stack of them right now. If anybody wants to spend a moment on a trick cheat sheet writing the additional stuff, you know what? You guys work on your homework. I have nothing to do for the next 20 minutes. I will add the tangents and the other formulas to the new trick cheat sheet that I'll print out. You are just going to add to it because nobody reminded me and I didn't remember that we had homework. Cool. Sweet. Do you want a quick brain break before we start?